So I passed the first test, which is you guys came back, right? So can't be that bad. We're going to power through this. I mean, I was talking with Jack at the break. You could have a whole day symposium or more on robotic milking and not hit the same topic twice. So there's obviously lots of things that are left out. There's the presentations don't follow the manuscript. I think I said that. So if you want to know more or more details, they'll be in the manuscript. I want to hit the highlights, and we'll power through this and get on to some other things that are non-robotic. So one of the things I see with robots that frustrates me is there's some unintended effects. So if you buy robots, or the way they're marketed to dairies, or the perception of a dairy when they get a robot, is that they're going to have an improved quality of life because there's going to be some separation between them and the cow. It isn't worded that way, but essentially that's how it results. The side effect of that is you have less direct observation, and we hit on that. If you milk your own cows, you've got a very intimate view of their teats, their teat health, the cleanliness, the behavior of the cows, the milking equipment, even things like we had one dairyman point out, you can hear your pulsators. I think we'd argue that's not a very specific test, but it's true. You can hear when some things go wrong, and maybe with a robot you might not get that experience. The other one that I see is robots generate a lot of data, and that's valuable. There's a lot of data that we could add to it that might be valuable. And Jack Rodenberg, again at the break, brought up we should be able to make a list of cows that we had to fetch and count that into our algorithms for something like mastitis. Because if you do have to fetch a cow, probably she's got some issue, unless she's just fresh. So we could add more, but the data that the dairies have, if you've got a large dashboard or a lot of metrics or a lot of sort lists, it tends to overwhelm. And by that I mean that we either don't know how to use the data, don't know which pieces we should focus on, don't know what it means, and a lot of times, how do we sort out the priority, okay? So a good example is when I started up, was part of the startup for that 24 robot dairy. The first week we had a sort of 90 cows a day for somatic cell count issues. A dairy cannot manage that. You can't check 90 cows a day. It diverts your interest from other cows on the dairy. So we want that list to be as specific as we can so that we're only working with the cows that we need to, but also make sure we're not missing those. And that takes some fine-tuning of the algorithm, and that takes some training from the company to be able to know what goes into it and know what thresholds to build into there. I also see that when you invest in robotic technology, you do want to manage with the data, which is good, you paid for it. But at the same time, when you start managing off of data, we become firefighters in a way, because we wait for alarms to go off. And I see this, I hear this a lot. Well, we had this issue, but I didn't get an alarm. Or I got an alarm, I don't know what it means, so I just turned it off, right? So, because you got to keep milking cows, that's reality. And so one of the ones I want to hit on is maintenance of milking equipment. The robots are set up to count cows and use that as your maintenance interval, and that's fine and dandy. But we can't just go on that, right? There needs to be basic checks. So things like you would in a parlor where you would graph pulsation, that still needs to be done in a robot, and it needs to be done on an interval that we're looking for these things, because we know when you're dealing with cows, things happen. It doesn't go according to plan. And again, as I said, each dairy utilizes their equipment differently. So that creates different use on the equipment, and that creates different lifespans. So I just highlighted some arrows everywhere we got valves and diaphragms. That's not everywhere, but you can just start to see there's a lot of maintenance points on these pieces. If you compared this to, say, a large square baler or something, there's a lot of uptime maintenance on those pieces of equipment because you need them to run. Compared to a combine or a self-propelled chopper, they're very complex, and you need to be invested in maintenance. And I know these, when you buy a box, it comes with a maintenance contract, but understand what you're getting in that. Understand who's going to do what, and understand how often we're going to do it. So again, not brand specific, but I picked out Lely here as an example. This is the components within an arm. So if I go back, this is just a view with the plate removed from the arm. These are the shut-off tubes, so this actually shuts off the vacuum. These wear, and I'll show you, I like to pop them out and look at them. They can break, they can do other things. It's a pulsation filter. I do like pulsation filters, but they do tend to suck up debris. So again, I don't like relying on a cal counter or an alarm that gives me a flow rate issue to know that this is plugged or impacted. Because by the time I generate an alarm, that has to create a deviation big enough to alarm. So I'd like to catch that earlier. It should be a planned thing that you look at on a regular basis. So that's the pinch-off tube that we talked about. Anything that shuts off the vacuum, we want to make sure that it opens fully, and we want to make sure that it's shutting off fully as well. So key maintenance point there. I would argue that the maintenance interval on components like these, and this is not unique to Lely, it would be same for a dealer valve. I think we really need to evaluate and say, are we running these a little bit too long? I hear comments like, well, I run my inflations till I hear squawks. Well, on a robot, and this is not a laughing matter because people post this on social media, and robots have their own Facebook pages. The logic in that is not sound because you don't have much weight there, so to create a squawk, it's got to be really bad. We want to be changing these before they impact how the cow milks, and that means customized maintenance intervals, not just running by the here is your box, here's how it operates, here are your settings. You have some responsibility as an owner, an operator, an animal caregiver to find out what the interval for this piece is and then change it at whatever that interval might be. I know it's a direct cost, so you have to write a check for it, but at the same time there are indirect expenses that are tied to this. And I'd argue if you have issues with these, even if they're not broken, it has a big impact on especially your high flow cows, your high milking cows. This is another one I see. So this is going to give you an alarm in the middle of the night. How often are you actually checking the things on the arms? This is the rope attached to the cup on a Lely. I pick on Lely a little more because I have more Lelys in our co-op, so I apologize. Again, I don't play favorites. They all have good qualities. This is something that we need to pick up now before it calls you at 2 a.m. This is one I see all the time. These are obviously the brush system, the brush cleaning system, and I would argue that these brushes, they might be fine based on the interval, but they surely need to be cleaned. That's one thing. So you've got a lot of debris up in there. You can't sanitize that, so you're basically brushing cows with bacteria. But also they're fairly worn out on the end, and depending where the teat places on there, that's probably telling you that either your teats aren't positioning well where you've got them on the brushes, or it's just time to think about changing that brush, even if the interval doesn't tell you it is time. So this is another example of that, and I see this a lot. This end of the brush is perfect. This end of the brush, which is the end that accepts the teat, you can see how frayed it is. So the cleaning and stimulation in this part of the brush is not going to be near the same. So again, watch where the teat positions within the brush. It should be in the middle. If it's just up front, you're going to miss more teats for one, but also you're going to wear the brushes out. Cleanliness should be self-explanatory. Again, no different than a parlor. The expectation in a parlor would be if you get manure on a unit, you're going to clean it off, whether that be manually wiping it off, hosing it down, taking it back to the wash sink when you're done with milking and scrubbing it, something of that nature. So if you're going from a tie stall barn to a robot, which I know some dairies have, in a tie stall barn you carried all your units back and you cleaned them manually. Every day we should be cleaning these manually too. I would argue that's a daily maintenance point. This is one that doesn't directly fall under milk quality, but this is a collection device for diverted milk. And I say this because I'm advocating for calves. I'm advocating for calf health. If you look at these units, they rarely get cleaned the way they should. This one is filthy. And so we ask ourselves, okay, why don't we get the growth we should? Why do we get bloats? Why do we have issues with calves? This is bacteria laden to a huge extent. So if you're going to use these devices, they have to be cleaned, just like any milk handling equipment. So don't forget about that. I want to highlight this one. This is a Dela valve. They've got a backstop for their liners, so when they detach from the cow, they're going to come back and slap here. It's going to drain milk on it. Every liner is going to be pulled through there. And if you leave it like this, if we were to culture that, you could grow all kinds of neat pathogens off of there. It's going to drag every liner through there. So a lot of this is just common sense. A lot of it is just looking around and saying, if this was a food plant, would we tolerate this? Because this is a food plant. That is what we're doing. We're making food for people. So yes, we can kill this probably with pasteurization, but does it have an impact on the final product? If you ask Saputo, they would say yes. Shelf life, consumer taste profiles, the stretch of their cheese, all those things come back to milk quality. And whether you can kill it or not is not the issue, it's was it there in the first place. So we have to think clean just like we do in a parlor. I'm going to visit real briefly on TTIP. We know it has an effect on milk quality in lots of different ways. In general, the teat dipping is not good on robots. And I'm going to say that, and then in the next breath, I'm going to say that's not a pass to not do anything about it. It's not a pass to not look at it. It's just, in general, we're not where we should be. And I think the manufacturers understand that, and I think they're looking at better ways to do it. Lely and DeLavalve are going to be teat spray. Gia is obviously dipping within the cup itself, the mouthpiece of the cup. When you're dealing with spray, it's no different than if you had a hand wand sprayer in a parlor. There are certain factors that change how much delivery you have and how much of the teat or udder you cover. And so this is just an extreme example of covering a lot of the udder but not all of the teat. And we deal with that. And we have to, I think in the short term we probably have to tolerate some of that, but at the same time advocate for getting better with it. So with sprayed teat dip, if you were in a parlor, the expectation would be that you would pattern that. So you'd find a way to pattern your cone off that sprayer, and you can adjust that. Most of the two brands that I referenced, they have different nozzles that you can change out that'll either give you a fan or a cone or a narrow profile to it. You can alter the pressure, which ultimately defines how much product you're going to dispense. And I think something for Canada that you should really keep in mind is dispensed volume is a factor of pressure, but also of viscosity, right? So how thick the dip is. If you have dip that's sitting outside in January in Northern Ontario, it's going to be a lot thicker than it is right now in June. So we should think about storing our dip in temperature-controlled places, or at least where we can moderate the temperature a little bit. I'll say up front, I have no personal experience with the A5 unit. I don't have any yet. I think there are places that do, and probably people in the audience that have experience. But their company people tell me that they're actually going to start using the teat coordinates, so the same coordinates they use to clean the teat and attach the cup, to apply the teat dip, and I think that's going to make it a lot better. I really think that will improve it quite a bit. So DeLavalve, this is from a DeLavalve herd I work with, so we didn't use a lot of dip, but we sure didn't get it where it needs to be. We missed both the rear teats, and we were too short on the front teats, so we got nothing there. This is not uncommon, but we need to be looking to figure this out, and we can do better. This is not necessarily just a fault of the equipment. This is a fault of nobody stuck their head under there, which, again, I get. There's a human safety risk to putting your head in there. So I'm not advocating you take unnecessary risks. I'm just saying we should try and look and get a mirror or get whatever you need to do it safely and try and figure out how good a coverage you're getting. You have two different settings on the robot for the spray pattern. When you call anything economic, that's the one the dairyman's going to choose if they have an option. So all of my dairies that run DeLavalves are on the economic, and that gives you this U-shaped pattern. I would argue on this cow probably the W would have had a better chance of at least getting the rear teats, but you do use, there's more dip use there, so you better hit more teats because you're going to spend more money in teat dip. This is a picture from my lone Gia herd of the dip coverage. It is somewhat variable. At least here I've got all the teat ends covered, variable coverage on the barrels, but they're putting dip into the mouthpiece chamber of that liner and covering the teat that way. There are settings on that robot, but I'm less familiar with them, so I won't cover them directly here. So if we were in a parlor setting, how would we evaluate teat spray? How have we done it in the past? Simple paper towel test, right? You can wrap that teat up. You could blot the teat end if you really want to check if the teat end is covered. You can wrap it and see if there's a blind spot. So these were all taken in a parlor, but the same thing applies to a robot. You don't have to check all 4 teats. You check one that's safer or easier to get to and see what your coverage is on that and check a few more cows. So I think it easily can be done. I do like to pattern the spray, so I'll hold a piece of cardboard or a piece of paper right at the udder when it goes to apply the TTIP. Again, you got to stand out of the way of the arm, so don't be risky unnecessarily, but you can hold a piece of paper in there and you can see what the pattern looks like as well. One caution here, if you're going to do this, if you were doing it in a parlor, there's always going to be a dipper or a sprayer there that you can reapply dip. If you're going to wipe it off, make sure you have a bottle with you, a cup with you so that you can reapply. So we're going to get into the bacteria count portion here. It's easy to focus on somatic cell counts, and I do a lot, but bacteria is a real consideration for manufacturers and for dairies. We do get paid on it, at least in the US. I think in Canada you do get paid as well. So I see more issue. This is, they asked me for some case studies. This is a case study from one of my dairies that I work with. It's a retrofit dairy, 10 boxes. And you can see here we've got very long runs of lines. So you got a set of boxes down there. You got a set here. They're all along the outside wall. There's another set, back where you guys are sitting, and then again along the other wall as well. And so you've got this long line, and they've done the best that they can to insulate it. But we have, obviously there's sections that aren't insulated, so that's a factor. The heat loss in this, you have a lot of surface area. You're going to lose a lot of heat. Heating water is expensive, but also it's the major component of most cleaning systems. But one of the other issues that we have, I'll go back. One of the other issues that we have is how do you set this up so that when these all wash at the same time, you're getting wash water at both parts of this, meaning you're not getting rinse here and wash here. Because when you mix cold water and hot wash water, you have sediment that falls out and redeposits on stainless. And so we see LPC count problems. We did anyway in this herd. I apologize again, not a better picture. But that line comes in over here, and you've got this buildup on the pipe here. It doesn't look like a lot, but this is enough to give you an LPC count of 200. In our co-op, the average LPC count last year was 25. Okay, so which is an aggressive standard, but again, it's important to what we manufacture. So this was a huge concern for us at the moment. I got to give credit to Ecolab for these graphs. I did not make them myself. I was a part of making them, but I didn't do it myself. These are Hobo graphs. So again, I said it's a 10-box unit. This is units 9 and 10 and 5 and 8. So how they plumb together and just temperature over time. You can see that 9 and 10 got to the point with high temperature before 5 and 8 did. So we had mixing of hot and cold wash solution. And one other issue that you can see there is these sets of boxes could not hold their peak for very long. So there's a little bit of discrepancy between the actual water temperature and the temperature of the pipe. So I don't read too much into it, but we got to about 153 with this one. We got to 155 with this, but we were able to hold it for quite a bit longer from boxes 9 and 10 than 5 and 8, which should be the opposite. That has the most line to travel, right? So you should have the most temperature loss in those units. So the fix in this case was we put a delay on the wash. So the boxes 9 and 10 now start after 5 and 8 do. So we timed them up. And so these are the after graphs, and you can see we did get both boxes higher. So now we're hitting at 160. Still have a little bit of issue holding that temp with those other group of robots, but they are hitting the same point at the same time. And this dairy has run LPC counts less than 20 for quite a while. So it made a big difference for us. I'm going to touch on this one, and I added this because I know there's a lot of debate here in Ontario right now. And I feel I can weigh in on it because my company has just committed to building a plant in Ontario. So we're going to be dealing with Canadian milk. And I told you how important bacteria counts are to the products that we make. These are buffer tanks. And I know you guys are wrestling with this issue. I think you have to, I understand the reasoning for buffer tanks. If you don't know what they are, it's basically a holding vessel for the time period when the tank is full so that they can stick the tank, so do your measurement, pump it out, and then wash that tank before they go back to milking. So it's just an accumulating vessel there. The challenge that you have with that is it's going to be in there I think an hour is conservative. I think till you do all that, it's probably an hour and a half to 2 in a lot of cases if we timed it. Again, I don't know how cold your well water is here, but if you're using a plate cooler system only, you're going from 100 Fahrenheit. Again, sorry, it's not in Celsius, but you're taking that down to 60 at best, probably more likely in the 70s for temperature. And in general, what I've seen here is we're putting those into a vessel that has neither cooling nor agitation on it. So it's going to sit there for 2 hours at lukewarm temperature. And I want to compare that for reference to the test that we run for PI count. So preliminary incubation count. It's not necessarily a popular test, but it's one that fluid bottlers like to run because it affects shelf life and some product characteristics which are important. So if you were going to run a preliminary incubation count, the standard for that test is that you run it at 55 degrees. You basically set it on a countertop almost or in an incubator, hold it at 55, and you do that for 18 hours. So lower temperature but longer time. And that's going to select for bacteria that are low temperature growing. So essentially those that will grow when you put it into cold storage. And these, by and large, are going to be gram-negative bacteria. So we just said there's no cooling on those tanks, and the milk is going to be 70, and it's going to sit there for 2 hours. So what do you think that does to your preliminary incubation counts? It's going to increase them. And again, the issue is not that you can maintain within standard, or that you can pasteurize it and not worry about it anymore. It's what quality could you produce if you didn't have those constraints? Because I think it's a global market, no matter how you look at it. If someone can make higher quality than you and that gives someone an advantage in the marketplace, I think you have to be cognizant of that. And so to me, this would be a concern that we can have a system where there's milk held without cooling for that amount of time. And quite honestly, if it was in a parlor setting, my understanding is that wouldn't be allowed. And it wouldn't be allowed in the US either. So I'm a little uncomfortable making exceptions for robots that we wouldn't for a parlor just because it's a robot. Again, if it's good enough for a parlor, if that standard makes sense, and I'm not the one to evaluate it, but you know the whole industry needs to evaluate it. If it makes sense and we did it for a reason in a parlor, I don't think that reason goes away as soon as you switch to a robot. So I'm going to finish with the meat of what I wanted to talk about, milking equipment testing in robotic milking systems. I don't see a lot of people out doing milking equipment testing, whether that's a dealer level, whether it's from Omafra or Guelph or veterinarians, and that's a missed opportunity. These are fine-tuned precision systems that dairymen pay good money for, and we should be out looking to optimize them where we can. And so I'm just going to show you a couple of examples. This one happens to be a Lely, so again, you're looking at the arm. These are the shutoffs we talked about earlier. This is their pulsator, and it's a brilliant piece of engineering. I will give them credit for this. They've got screws on the top that allow you to completely adjust the phases of pulsation. Brilliant. I love it. The challenge with it is whenever I graph pulsators, I almost never find one where all four are adjusted the same. Now digest that for a second. I told you earlier that we're relying on an alarm based on a deviation to find when we have a maintenance issue. How accurate and sensitive is that going to be when you don't have all four quarters set up to milk the same? It's little things, but I'm telling you, when you're aiming for the highest quality milk you can produce, it's a game of details. I think it was said best in the short course yesterday, it's not about doing one thing 1,000 times better. It's doing 1,000 things 1% better, right? So can we up our game? I would argue we can. It just takes graphing these in a couple seconds to adjust it. But again, if you don't look, you're not going to find those things. So just so nobody thinks I'm picking on brands, this is a deal valve. And so this is the milk side, this is the pulsator side. So does anybody recognize the problem here? This did not create a deviation alarm, by the way. It did not. We all know periodically hoses fall off, get kicked off, and what do? When the alarm happens, we go there and we put it back on. Okay? But what happened between that time and when we put it back on? Here we got a lot of I would consider it mostly manure sucked up into that pulsation side of that hose. There is not a robot testing standard, and I'll address that at the end. So this is what I'm going to talk about is relative. This is what I do, okay? It doesn't need to be what you do. You don't need to agree with it, but this is how I've adapted to testing in robots. I do like to use the Videa unit. So you'll see this is on 2 different brands. There are challenges with that. We'll get into it. But what it allows me to do is put this unit on and not impact the milking of the cow. And I think that's big. And there's some discussion points there too. But if I stand right here, this cow doesn't want to come in the chute. She doesn't let down like she normally does. She might be uncomfortable. She's not used to that. I can't stand right here. The other side of that equation is if I want to do all the other things we talked about, swab teat ends, score teat ends, strip yields, I can't be standing and running a piece of equipment. So I put this on. You might say I cheat. I actually tap right into the hoses. I offer to replace them for the dairymen. It's a small fee, but it's easier for me than doing some of the things we'll look at later. Like Lele does have a test cap you can put on here. I would argue that changes milking too, but there are other ways to test it, but I will put a port right into, even with silicone. I know they say you're not supposed to do that. I do it anyway. It gives me good numbers. I would argue these pictures, the one thing that's missing here, we probably should have these be filtered, okay? And I don't. I'm risking my own equipment doing it. But there is fluid that will get in this line, and you got to come back and you got to drain it periodically. And if you don't, every once in a while you will have a unit that either the vacuum calibration gets way off, or you just have to send it in and they got to rebuild it. So I've elected not to do that, but that's a risk I take and not one I would recommend everybody take. So I interact with the companies as much as they'll let me, and so I had a healthy discussion with Lele, and they've been very, very good at talking these things through with me. And so the fine people at Lele said, well, isn't the weight of this impacting the way the cow milks? And you could argue that, I suppose. And I've offered to do some research with them on it, and we haven't gotten a chance to do it yet, but someday I will. I don't think it does. I don't think it has a huge impact. But if you do, that's fine too. You don't have to do it the way I did it. So in this scenario, all I did was put a piece of electrical tape down on the arm, and I stuck the Videa to it. I would probably wrap this in a glove, and we just ran some longer tubes. You can see how I attach them, and so I just tap in. So here we tapped into each of the different cups. You wouldn't have to do that. You could do pulsation and vacuum on 2 cups because you have 4 channels with this scenario. But this gives you another alternative, and this does work. You can walk away from it, and the hoses stay on, and it collects the data for you. So I will give you another word of caution, and I've ruined a few Videas, and it's not cheap. If you're using steam cleaning, turn that off, okay? There is no filter in the world that protects from steam cleaning. So please make sure you go in. If you're going to hook up test equipment, and that doesn't matter if it's an SA2, a PT5, a Triscan, have them turn off the steam cleaning for you. And just to show that I'm not biased, and the people at Biocontrol don't pay me or give me anything, this is Don Anderson's SA2, and we did all the same testing with this SA2 that we do with the Videas. So in this case, my recommendation to you is leave enough hose that you can disconnect and walk away. So let the cow come in, let her get prepped, then walk in, hook up your unit. And the other advantage to having enough hose is that you're out of the way of the arm. Because the last thing we want to do is have someone get hurt. So, I apologize, this should be rotated, but part of my job is to ask questions, right? I advocate for dairymen. A good friend and colleague of mine, a great mentor, Andy Johnson, who was unable to be here, unfortunately, he taught me that there's great value in advocating for your dairies and advocating for your cows. And so I just ask questions, and if you do enough of this testing, you find oddities with robots that I don't think we'd tolerate if it was a parlor setting. I'm not going to tell you this is wrong. I'm not going to tell you this is bad. I don't know that. But I've never seen it in a parlor setting. So if you're de-valve because you got long hose, they can't just shut the vacuum off. They have to lower it first and then drop it off, okay? Because you can't pull the cups, and it's not reactive enough because you have between 13 and 15 feet of milk hose there that you're dealing with. So they lower the vacuum down and then break it to atmosphere. I don't know what the impact of that is, but I've never seen it in a parlor. I've never seen that happen. So I'm just asking questions. It probably has no impact on the cow. Again, I don't know, but I see it. This is my setup for doing receiver vacuum. I would argue we should be doing all the same tests that we do in a parlor in a robot. If you had a parlor or a tie stall barn and you got an airflow done every year, or your dealer did effective reserve every month, there's no excuse not to do it in your robots. Again, if it's good for a parlor, it's good for a robot because we're using the same principles, the same physics. The pulsators do the same things. The liners have the same actions. So if it was good in one, it's good for the other. And so this is how I set it up. I use, this is a GIA sampler. It goes on the bottom of their milk meter. I use that. I connect it to the top. This would have been a spray ball here. I just take that out. Here's it in a Lely. I can just set it right into that break there. It fits in nicely. And then I just connect Vidia. Again, an SA2, PT5, Triscan. Any of those would be good. And this gives me the option to do an hour or two of system vacuum, receiver vacuum. And again, I'm doing that because I want to make sure it's stable. I want to measure it for a period of time. And so, again, I'm just pointing out irregularities that I see. This comes from a Lely system. Lely has a different approach to providing airflow to their systems, and they've opted for a lower airflow system. So one of the consequences of that is when you're supplying two boxes with a very limited air supply, there are periods of time where you have a certain amount of factors align. The most common one I've seen is when you're using the bladder pump to pump out an A4 and you're attaching on the other side. So you're doing two things that use a lot of variable air. The system doesn't compensate well and you get this yo-yo effect of your receiver vacuum. Assuming this cow, which she did, had at least one cup attached, there's an impact to that. We made the NMC system testing guidelines for a reason because we agree that there's an impact to that. Doesn't happen all the time. You can make really good milk quality with a Lely robot, but you see this from time to time. Part of that is, again, I said how they elect to supply their vacuum. So in a Lely system, you have a small vacuum pump. You've got a VSD, so a variable speed drive controller. This is at the vacuum supply box, and that's routed out to two other boxes that each have a regulator out at the box. So if from a milking equipment standpoint, I used to work for a milking equipment company. I know there's a lot in the room. That's probably not the most efficient way to regulate vacuum. When you've got two different things that are trying to counteract vacuum within the system, it's probably not the most efficient. Does it mean it can't work? No. I'm not saying Lely's bad, not saying it doesn't work, but it is a consideration. And so I want this to lead into my final shot over the bow. And that is that we desperately need a consensus on how to test robots. There's going to be more and more of them. And if you use the NMC system guidelines, if you test by those standards, there's going to be a lot of robotic installations that fail. The most common request I get from dairies, whether they be my clients or consulting clients outside our co-op, is tell me my milking equipment is not part of my problem. And today, it's very difficult for me to do that. It's very difficult for me to stand in front of a dairy when I know it doesn't pass the system analysis guidelines and say your robotic milking system is not part of the reason you can't achieve the milk quality that you want. And some of the guys I work with have very aggressive milk quality guidelines. So again, I'm not saying it's going to fail, but I also can't tell them that it's not part of the reason. There's a lot smarter people than me that developed those guidelines years ago. And so as an industry, we either need to say, you know what, those guidelines probably were a little bit misguided and they need to be updated and it needs to apply to everything, or we need to say robots need to be the same standard. And I don't know which, but the field needs guidance on how to test a robot and what standards we need to hold them to. That can come from NMC, but it can also come from people in the field. And I'm confident if more of us get out and start doing some of these tests and start informing producers of what the results are, I think that the manufacturers will come to the table and agree on a set of standards. So that's my request to you guys. Again, go forth and do something different when you get home. When you're out in the field next week, do something different than you did last week. So with that, thanks. Appreciate it.